Thank you for joining this afternoon's second webinar of our Tech and Data series, Data Management. My name is Mahdi Iskandari. I'm Program Manager with McMaster Continuing Education, and I'm very pleased to co-host today's session and to welcome my colleague, Guido Di Cesare, Data Analytic Program Instructor. Before we start, I would like to acknowledge and recognize that McMaster Continuing Education is located on the traditional territories of the Mississauga and Haudenosaunee nations and within the lands protected by the Dish with One Spoon, One Pond agreement. Now, I'm handing over to my colleague, Guido Di Cesare to start.
Hi there. Welcome to the session. As Mahdi said, it's a discussion on what is data management. Basically, in this session, we're going to explore the importance of managing the data, because as we all more at the enterprise level, but more from a pragmatic approach, from a pragmatic perspective. Because, without a solid data foundation, your operational systems, your analytical systems, they will not operate efficiently. And basically, the data is the structure that supports a lot of the analytics that's being done. Okay. Let's go on to the next slide here. Okay, so what is data management? The official definition is the planning, execution, and oversight of policies, practices, projects, that acquire, control, protect, and deliver and enhance the value of data. So in essence, what this is saying is like data management, as you can see on the diagram on the right, impacts a lot of areas: data governance, data architecture, warehousing, data warehousing, transformations, data management, the proper policies and standards for it touches all the areas, all specific responsibilities. Yeah, and the purpose of, like we said, the purpose of data management is to store, protect, and ensure the integrity of the data, to continually improve the quality of the data that you're working with, and ensure that everybody's using the data effectively. Okay, and it's also to ensure the privacy, confidentiality of the data you're dealing with. We're going to get into some of these detailed discussions further into the presentation. So basically, let's start with what is data and its importance. Like data is, as you know, is one of the important assets within a corporation. Unlike any physical asset, it can't be touched or moved. But data is valuable and it's durable, and like I say, data doesn't wear out. It's basically plain facts collected during the operations. It is a raw material that almost always contains useful insights. Okay, basically, when we have the data, you run it through a process and you get information from it. And the data has value when it's delivered in a timely, properly formatted, concise, accurate, and understood. Okay, the challenge is that these valuable insights are often well camouflaged within the data. This is why you have to usually do your analytics, is to be able to extract going through the process to extract the knowledge or information out of the data. And as we all know, companies have vast data assets, and to become more of a data-driven organizations, they need to understand the data. And this is what data management helps you. Data management helps you understand your data, maintain your data, so that you can get valuable insights from the information that you're storing. Okay. Now, what's happened? Like, what is this growth of? We have a growth of data occurring, and what is driving the growth of data? Basically, it's just from some of the numbers here. Smart cars generating 1.4 terabytes of data, okay, per hour. We have tweets, 20 million tweets per hour. Google generating 3.5 million searches daily. Wearable technology. We're all generating all this data, okay? But we are constantly collecting data and generating data, and we want to be able to align it and connect these various disparate data sources to get some insights out of it, be able to better address our customers, even find out more efficiency, to find more efficiencies within our organizations. And it just seems like we seem to be measuring everything, okay? And as we accumulate this, it's essential that the organizations learn how to leverage this data to make smart decisions. And to be able to leverage the data, you need to be able to maintain the data efficiently so that you're using the data properly. Okay, so why is data management important in today's environment? Like I said, the data your organization creates is a very valuable resource. Okay, corporations that manage their data efficiently can provide enhanced services Like by that, we mean customer services, reduce costs, enhance the customer experience, and operate more efficiently, and help companies move towards this becoming more of a data-driven organization where they can use the data, the insights, the analysis to help the organization move further ahead and help their customers. Okay, but with well-managed data can also aid in good corporate governance. And by this one, we mean it's to be able to provide an organization's management with a comprehensive and concise view of the organization's activities and the data. So where everyone is using the same data in the sense that when two different departments produce reports using the same data, on the same data, they get the same results. Okay, it's and by organizing the data efficiently, we all go to this. Everyone uses the same data for their analytics. One thing, but deriving the value from the data does not happen in a vacuum. Okay, so this data needs to be investigated and prepped properly so that the organization can start using the data and to answer any questions associated with it. And again, this is where your data management comes in. And again, companies can better realize their potential of the new tools that are available to them if they have a better understanding of the data. A lot of the tools that are out there right now have a lot of capabilities. They have some of them have machine learning capabilities, AI capabilities, and if the company understands their data and how they can feed it into these tools, you can get very good results. The flip side, the cost of poor data quality is enormous. As bad, and I'm sure we've seen this, as bad information moves throughout the process, the cost of correcting the information increases. So you want to make sure that the data is as good as possible, as good at the beginning, because it goes through the various processes, whether it's analytics or operational, it can give you, it can cause issues with other data streams that you're dealing with. Okay, I'm sorry, keep talking ahead of my slides, I apologize. I just meant to say what poor data, the cost of poor data quality is enormous. The value proposition for data management. Again, I taught some of the items in the previous slide, but it basically deals with data quality, efficiency, and business value. From a data quality perspective, it provides tools and techniques to define and document the data quality standards, makes the data and quality definitions and edits available to all users through the use of the metadata, which is a component we'll talk about later. It assists in defining the data and data quality standards. Again, I'll be talking about these in this further slides. And also assists in the creation of population of data warehouses and data lakes, which again, we'll talk about later. But basically, these are things that you need to maintain your data quality. Also, the other value proposition for data management is efficiency. Proper data management will help you reduce costs of the data collection and storage, could reduce systems complexity by, instead of having many silos of the same data, you create the data once and everybody uses the same data. Again, whether it's analytics or for operational purposes. Also to manage the data content and definitions across the organization. Different departments, when they say order or customer or product, they're all talking the same terminology. Also, from another efficiency perspective, it simplifies the data translation activities for operational data stores, data warehouses, and data lakes. And also it advocates for industry and enterprise data standards to ensure consistent definitions between yourself and even with your partners. But the big thing from an efficiency perspective, it promotes the interoperability of the data and the databases. And another value proposition from the business value, it reduces the complexity and costs associated with the proliferation of data. And again, you reduce your silos that are out there, reduce the cost of storing the data, the cost of sharing the data, and provides for the business ownership policy and the planning of the data. Okay, and also the ability to react to market changes quickly. So you know your data, you know what's out there, you know how it's defined. You don't have to. A lot of time is spent just figuring out what data you have and how you can use the data. There's been numbers presented, like in analytics, you spend say 80% of your time just finding out what data you have. If you don't have to spend your time doing the analytics, you're spending more time actually developing your insights and even updating your operational systems, and significant cost savings from there. And also from a business value, it ensures that the using data management processes which we'll talk about in the subsequent slides, it will ensure that the information stays secure. Okay. So basically, the value proposition for data management, it increases your data quality, efficiency, the business value, all to help move your organization ahead. Okay, so the topics we're going to be talking about are, like I said at the beginning, this is a pragmatic approach to data management. And we said this is not a sales job, but we teach, these are the areas we talk about as part of McMaster's data management course. And there's basically three main steps. You have to organizing your data, curating the data, and exposing to discovering valuable insights. Okay. So to get started, you need to put order to your data to assist the folks that are doing the analysis. So we're going to start with organizing the data. Okay. Even though I've only listed 3 points here, information modeling, what is big data, data lake, and data warehouses. These are the big topics that areas that are very important. You have to get a good control on these environments, just to organize the data that you have. Like information modeling. Like the purpose of information modeling is to define your business needs. Okay. Basically, it helps you understand what data you have within your organization. Okay. And also, information modeling helps you facilitate the planning and implementation of integrated information architectures. Okay. So now you know how the various architectures are out there and how they're using the data. It contributes to data sharing and integration. Instead of everybody going ahead and building their own silos, once you develop your information models, you'll get to see how all the data is related, so you'll know where to get your data. And I'll explain those once we get into the pyramid. It promotes data independence away from the technology. You're not tied to the technology, and provides the basis for database design. Basically, it's a rigorously defines the organizational objects, facts, and rules. Basically, the what content. Okay, and again, it's all to help the business move more efficiently. Also, for folks that are doing analytics or doing even development, it helps determine if they have the correct data, and they are able they have the correct data to do their analysis. Like they usually start when you're doing it, you start at the top. You use a conceptual bit. You start with the conceptual models, and this is where usually the business stakeholders start. And basically, it's a communication definition of business rules and terms. Okay, so basically from there, you step down more into the logical. You start developing your logical data models, your logical entities, and this is where your data architecture and your business analysts work. It's more deals with the classification of data, the business rules, and the data structures. And the third layer, the physical layer, this is where a lot of your analysts work, your DBA, database architects, database analysts, developers. It's more the technical implementation of physical database. And this is where you start dealing with hierarchical databases, network databases, relational databases, graph databases. And this is where information modeling, data management, the information modeling under the umbrella of data management helps you understand, model your data right from the conceptual level all the way down to the physical level. So when you're starting to figure out your data, okay, I'm dealing with customer data, where does it exist from at a conceptual level? And then as you work down the various levels, it shows you what other relationships it has with other data at the logical level, and then where it actually lives. Like I say, this is why the information modeling is very important. Data management, information modeling is very important under the data management umbrella, because this is where you basically get a view of all the data that you have at both the logical, the business logical business level, and at the physical level. Okay. I talked those 2 points. I'm sorry. I get carried away when I'm talking sometimes. Okay. I'm going to get into a discussion of big data. Okay. We've all heard of big data. Big data is out there. What is big data? And in essence, big data is data whose scale and distribution or timeless requires a new technical architectures. Like some of those physical databases designs I mentioned earlier may not be able to handle the large volumes of not just the unstructured data, but the large volumes of data that we're dealing with. You see from the other side how much data is being generated, and some of the technology, some of them have upper limits. of how much data they can store and also the process they're running against them. So this is where what big data is about, okay? And big data projects frequently include data of multiple types from both traditional and non-traditional sources. By traditional, I mean your relational databases, your hierarchical databases, your network databases that we are familiar with. Then you have your non-traditional sources. You got your streaming data. You have your Twitter data, social media data, and it's nice. Depending on the type of work that you're doing, it's nice if you can put these together. And depending on the problem that you're doing, it is very effective to put them all together. But there are four multiple characteristics of big data. The four stand out. You know, you're dealing with a huge volume, a variety of complexities of data structures, the velocity, it changes very quickly, and the veracity, like how valid is this data? Okay, huge volume of data. It's just there's a lot of data to deal with. The variety of complexity of data types and structures. You mentioned earlier, you depending on the work that you're doing, you may have to integrate many types of different database systems, relational, hierarchical, network, graph databases to get the information you want. By velocity and speed, like this data changes very quickly. I'll show on the next slide how fast this changes. And when you're doing your analytics, you want to be able to manage the data or put in place not governors, but be able to manage the data so that, if you run a report now, then you run it 5 minutes later, you're most likely going to get different results. But at least if you understand why you're getting different results, it helps. The veracity is the validity of the data. If you're getting data from one stream and another stream, especially in social media, do they all define customer the same way? Do they all define the products the same way? If you're trying to mesh this together, you want to make sure that the data is valid. And the other thing with big data is that you've heard the term structured, semi-structured data, quasi-structured, unstructured data. This is dealing with data if you're dealing with XML type of files, which is on quasi-structured data, semi-structured data. Unstructured data deals with text documents, PDF images, being able to process this type of information, or refer to them as binary large objects or character large objects. And this is where there's no inherent structure to the data, but you still want to be able to analyze it. That's what we mean by unstructured data. Whereas structured data, everything's defined, like a relational database, IMS database, traditional things that we deal with. The data is defined. A customer will be in this field, an address will be in this field, product will be in this field. But as you start getting into the more semi-structured, quasi-structured, and unstructured, there's no specific rules to where the data is, and you have to analyzing that data could be kind of complicated. And this is where some of the big data tools that are out there, like your Databricks, your Hadoops, are geared for doing processing on that type of data. Okay, this is what I meant to show before. Like this is, but more from the velocity. This is showing every minute of every day. I'm not going to read these, but shows you how much data is changing. Okay, Instagram, it shows 3,600 photos every minute of every day. Like Apple receives about 47,000 app downloads every minute, 100,000 tweets every minute from Twitter. This is how fast the data is growing. And we're capturing all this, and capturing all this is very good. But then you have to put it all together. In this slide here, isn't it nice? Well, I'm sorry, isn't it? The technology is there now to do this, but we need to manage the data that we're generating to be able to get insights, be able to pull all this information together. So as this data is changing, you want to be able to process it to get valuable insights from it. Like we said earlier, to make your company more efficient, to be able to send products to your customer, make your services more efficient. In some cases, you want to be the data you're analyzing for healthcare. Okay, real time. You're getting real time feeds from medical devices. You want to be proactive and in addition, identifying any issues that are out there. If you're a fire services or a police services, if you can start processing this Twitter information or a lot of this data that's out there in real time, you'll be able to. It has been done. be able to identify, do some predictive analytics, be able to define where crime may occur or where a fire may occur. But it's now the technology is there to put all this together. But the important thing is you need to manage all this. You need to manage the data. You need to manage the quality of the data. And this is where I'm going to talk in the next slides, more the curating of the data. Okay. You may have heard of the term data lakes and data warehouses. It's not data lake versus a data warehouse. They work together. Okay. Like the data in the data warehouse is usually it's consistent. It's stored. It's the day before you put the data in there, you plan it out. Okay. The data is structured, clean, organized. It's a long range planning, and before you design the database, before you implement the warehouse. This is used for a lot of your business a lot of reporting, your traditional business intelligence reporting. But this is usually the data is clean in here, okay, and it's used for various purposes. Even for in some cases, there's some what's called active warehouses where they use it for operational reporting. But this is where there's no surprises here. Then you get into what is a data lake. Basically, a data lake is a repository of data stored in a natural format as it comes out of the device or where you stream the data from. And it can include structured data, semi-structured data, binary data, images. The way it normally operates when you start to work with new data, the data lake has a lot of information, a lot of data. It's unstructured. You obviously have to manage how you store the data in the environment, or you're going to end up with, you probably have the term a data swamp. You can start putting data into it, but you got to know, you need to know what is in the data lake. And the developers, the analysts, they usually start their analytics with what is in the data lake. And once they have a better idea of what the data is and how they can use it, they move it into a data warehouse. It becomes more production ready. And like we said, it's large, undefined, raw data as it comes off. I'll use the telephone switch. As it comes off the switch, the data warehouse is more structured, refined. The volumes are smaller. It's normally a relational database. And it's, and like I say, it's not one or the other. These two work together. Okay. Yes. Okay. So what we're going to get into now, just a sec. We're going to get into a discussion on curating the data or organizing the data, the processes involved in organizing and maintaining this data that you have. There's been, Gartner, a lot of other think tanks have said that the preparation of data is an iterative and agile processes, and it takes a lot of time and cleaning, and about in some cases, if you don't have a proper data management structure in place, you can spend as much as 80% of the time in doing analytics and understanding what data you have. How do you pull this data together? What do you do with the data? Where is the data that I need? So we're going to get into a discussion of curating or organizing the data, so it's much easier for you to find where your data is and what you're dealing with. Okay. Let's start off with the data quality. Okay. So basically, data quality is a perception or assessment of the data's fitness for its purpose, for the purpose that you're using it for. And the reason I say it's a perception, in some cases, you may want to keep noisy data. You don't want to have clean data. Depending on the type of analytics or type of operational systems you're running, if your perception is the data is, you mentioned earlier, like just raw off a switch, you want it to be noisy. You want all the issues to still be in the data because you want to use that information to help you determine where there's issues. In some cases, the perception is I need the data 100%. If you're running a billing system or some sort of reporting system, troubleshooting system, you want the data to be pristine because you're going to be generating bills with that type of information. And like the quality of the data is determined by factors such as accuracy, completeness, reliability, relevance, and how up to date it is. And there I have more dimensions in that chart on the side. It's the timeliness, validity, uniqueness. These are all dimensions that you need to deal with when you're dealing with your data quality. And again, as the data becomes more intricately linked with the operations of organizations, the emphasis on the data quality has gained much greater attention. This is why a lot of time is spent on making sure the data is effective, efficient. You may have heard some of the arguments that they're having, especially in discussions they're having in the AI world now. You know, if the data that you're using for if the quality of your data is bad and it gets fed into an AI system, it can cause bad results to occur. And this is why you need, there's been a lot of discussions in that right now, lately. And this is why you need to make sure that the data is as clean or as best quality as possible, especially if you're going to be using it to feed some AI type of systems. But even in your traditional business environments, you want the data you want the quality of the data to be as efficient as possible. An example here is a retail example. Okay, you want to be able to identify identity recognition. Okay, as online customers increases, the need to disambiguate identities becomes more important. By that, I mean, if I come in with my first name or my last name or my phone number, you want to be able to understand that, yep, that's Guido, that's the individual. Whether I come under different personas, you want to be able to tie all that together because you may be able to offer different services to me. Also in social media, you want to be able to combine, again, social media gets a bit more complicated because you have numerous unstructured data sources to deal with. And you want to supplement that with other information that you have, customer-centric processes for improving the customer experience, streaming, one-on-one marketing. And again, this is why you want to make sure that the data you're dealing with is good, okay? Yeah, and again, this is to bring the data, again, the data quality, the data unification or integration is a set of activities to pull all this data together. So again, the definition, going back to the beginning, data quality is a perception. Depending on what you're doing, you may want 100% clean data, or you may want noisy data. It's also based on the type of reporting or type of business processes you're running. Oh, okay. I'll talk about data quality further down. Data cleansing. And again, data cleansing refers to the operations and removal of non-relevant information or noise from the content of the data. Okay. As I mentioned earlier, you may want to remove noisy data or data that's not pertinent to the analysis that you're doing. You want to standardize data and eliminate duplications and inconsistencies by using advanced standardization mapping routines. Okay, routines such as mapping of the elements, phrases, and pattern standardization to cleanse your data. The techniques also used are deduping, removing duplicates, removing default values, resetting dates, matching and merging data. Okay, and again, this is a data cleansing cycle. The steps that are performed when cleansing your data. And again, this is under the umbrella of data management, because under the data management umbrella, it will help define how you import your data, how you merge your data sets, how you standardize and normalize the data. And again, the data cleansing is the activity, but again, data management helps you structure, identify what you have to do to keep your data cleaned. Okay. Okay. Again, another important thing with data cleansing, depending on where you're sourcing your data from, you may get data that contradicts. One piece of data will contradict another piece of data. And this is where your data cleansing routines or activities are very important. Okay. Data profiling. Data profiling is a process of examining the data available from existing sources and collecting statistics and information that summarizes about the data. So basically, what helps you decide if you have the correct data. Actually, data quality and integrity issues include the valid values, multiple formats within the field, non-atomic fields such as long address strings, duplicate entities and others. And this is where you profile the data to see, is it really the data that you need? for the type of analysis or type of operation systems you're developing. It also ensures the accuracy and completeness, the validity of the data, which businesses can subsequently use to support their objectives. Okay. It involves the explicit analysis of source data and comparison of observed data, characteristics against specific data quality standards, and data profiling analyzes several aspects of the data, the characteristics, the relationship between fields, the data values, comparing the results, assists in understanding the quality source data, understands the issue, and understanding any issues if they appear. And again, this is the type of information, how many duplicates do you have? How many null values do you have? Are they unique values? Are they non-unique? And by data profiling, helps you define, you're basically profiling the data. Is it the data that you need to do your process? Sometimes you may want duplicates, sometimes nulls are good, but this is where data profiling helps you. Metadata, again, I'm running through this kind of quickly, but these are all the main activities that data management manages, if you will, puts in place the proper governance rules, standards, quality guidelines to do data profiling, to do metadata, to do data cleansing, to do data quality. It's under the umbrella of data management. Metadata is an integral part of data management because it provides the contextual information for business data or any data that you're dealing with. Again, it provides information about the context and usage of data for architects, developers, and analysts. It provides physical data, technical and business process, the rules associated with the data, constraints on logical physical structures. They can provide descriptive metadata, the ownership definitions, business rules applied to the business rules applied and the business glossary terms. Basically, the metadata helps you understand your data and helps you reduce your inconsistencies. As an example, the chart here, the picture is the data. Okay, this is what you have, but the metadata explains everything about that picture. Like the person who captured it, the data was captured, the files, the cameras, the lens, exposure. That is basically the metadata is explaining the data. And there are many tools out there. Many tools that are out there that are capturing the metadata. And this is one of the first places you should be going when you're finding out what data you have, is taking a look at your metadata repository and see what data from both the business perspective, technical, the business rules. A lot of this information is stored within a metadata environment. Okay. Okay. Another important process is a data lifecycle. And basically, the data lifecycle is about how you handle the data's full lifecycle, from their creation to the deletion when it becomes obsolete. Like on the left side of the diagram, you have many data streams coming in. Usually in the circle, I have all the operational systems that you deal with that accept the data. I have a data lake and a data warehouse, but it just was too much to keep this diagram, will be too busy. But basically, you have many sources coming in, and you acquire the data, cleanse it, you do the data analytics, then it gets data analytics and modeling, archiving, and purging. And the various groups here on the right side are using that data and information. Two things I want to stress here is archiving and purging. When the data, you're done with it, it has to be archived and it has to be purged at some point. Again, this is where data management helps you define the rules of when do you archive the data, okay, and when do you purge the data. In some cases, depending on the industry you're in, the data you're gathering, you may not want to keep. Doesn't make sense to keep the data forever. From financial perspective, you should be deleting your data after every 7 years. Okay, your financial data. And again, and this is where data management plays an important role in helping you define how you archive your data and how you go about purging your data. Okay. Another important piece is data governance under the data management umbrella. Data governance ensures you have high quality data exists through the complete life cycle of the data. The key focus areas of data governance are the availability, usability, consistency, integrity, security, and ensures a process to ensure effective data management. The data governance sometimes you look at data governance as policing. It's not really policing. It's the formal orchestration of people and processes and technology to enable an organization to manage its enterprise data. And again, this is all under the umbrella of the data management domain. Okay, and again, just make sure that that you have the proper guidance rules in place to help manage your data. Discussion of master data. Master data, again, as you see from the diagram, is we'll use my famous example, customer or order. Instead of having many silos of, here we go. The facts, okay, the facts describe the core business entities, customers, partners, employees, bill of materials. But you want to create this once, okay? You want to store it in one area, which is the master data, and everybody sources their data from that one source. If you have to make another copy of it, you want to minimize that, but at least you know where the data is coming from and how it gets refreshed. Let's say this high value information crosses many business processes. And the main thing, it decouples the master information from individual applications. So, like we mentioned before, partners, everybody accesses the same partner database, the same employee databases. You're not every application, or every analytics team, every modeling is not creating their own little silo, which as this grows, it gets more difficult to maintain, which can also end up getting bad results when you're running your reports. Or may get inconsistent results if everybody's sourcing the data from different repositories. In a lot of organizations, this data is scattered within application silos across the enterprise on various platforms, which makes it difficult to sometimes get a better understanding of your data. There's been situations where, two different teams have produced the same report. They're reporting on the same item, but the numbers are different. And they look over to me and he goes, fix this. Why do we have the same reporting on the same data, but different reports, different numbers? And it's because they're sourcing their data from different sources. And master data management, MDM, is a method used to define and manage the critical data an organization deals with to be able to provide data integration and a single point of reference. Single point of reference, we have reference data management. And this is where it's data defined to a set of permissible values to be used by other data fields. Reference data gains its value when they are widely reported and widely referenced. And again, these are different than master data. These are like they are warehouse. It's consistent, postal codes, stock numbers. They don't change, but instead of every group creating their own repository of a postal code, which can get out of sync, they create a reference data management, one repository which everybody accesses. And again, this is under the umbrella, like again, data management helps you put in place the governance and guidelines to manage this reference data. Security and data privacy. Again, this deals with protecting and modifying the data so that we can still pull and analyze the data as needed without compromising the security or sensitive information. Is that when you don't want to be able, because you have access to all this data, you don't want to disclose any sensitive information in gathering in the gathering and analyzing and publishing of this information. Because we're collecting, sorting, and analyzing and mining this data, an enterprise or a team can obtain large amounts of individuals' users' sensitive information, and due to the growing popularity, developing the data mining techniques that are out there, robust security and privacy protocols are required. And this is why again, I've differentiated security and privacy. Security means it's more like the environment's protecting your data. The privacy is who has access to that data. Okay, the data removal, the policies associated with this. And again, this is all under the mandate of data management that helps you put the proper data security and data privacy in place. Another item, oops, I'm sorry, I tucked ahead of my slides again, I apologize. Okay, data handling ethics. I'm cognizant at the time, maybe timing out here. Data handling ethics. You need to make sure, again, ethics is a big item right now, especially in how you're handling the data. Like I mentioned earlier, with data mining and information that you have access to, you have access to you need to protect the data and the quality. And you need to establish data handling ethics, establishing the definition of scopes for the ethical handling of the data, definition of the ownership of the data and the results of the analysis. Because people are showing increasingly concern lately with the privacy threats exposed by mining of their data. And this is why you need to have ethical rules in place or of how you're going to be managing the data ethically. A customer may come up to you and say, I want you to delete all the information you have on me. So you need to be able to do that. Or what information do you have on me? You need to be able to pull that information off for them. And basically the need is to safeguard sensitive information from unsolicited or unsanctioned disclosure while preserving the utility of the data. And this is ethics is a whole area in itself, but again, it's under the data management umbrella. It's just basically making sure you're handling because you do have access to a lot of private information, a lot of sensitive information. You need to make sure that you put the policies and guidelines in place that you're going to be managing efficiently. Another topic that I wanted to talk about under the data management is how do we go about exposing and discovery and getting valuable insights of this data. Data mining. Data mining is a process of extracting useful information and patterns from disparate data sources that are out there. Due to the volume and variety of data, it's an approach used to obtain the best view of the data to be analyzed. And once this information and patterns are found, it can be used to make decisions for developing the business. And again, like data mining is, as it says, you're mining the data, going to various sources, looking for nuggets, looking to see what data do you have out there that you can use to optimize your operations, your customers' products, your certain different type of services that you can offer. And we'll get into it a little bit later. There are various tools that you can use for data mining. But again, it's just going out there and finding what data is available. Another area another item underneath exposing and discovering valuable insights is visualizations. And this is just turning insights into actions. Basically, this is the data storytelling. This is when you get all the data that you have, and now you need to present it. The last thing a person wants to see is a chart, or in some cases, a chart with a bunch of numbers, Excel spreadsheets with a bunch of numbers. And this is where data visualization helps. Like the example I have here, I think people would rather see, how the data scientists spend their time. Oh, there we go. This one says 60% of the time is spent organizing the data. It's much easier to see it on a pie chart like this than it is to just, numbers on a screen. And again, it's an art in doing visualization and telling data storytelling and telling the data in a manner that both technical and non-technical people can understand. And good data visualizations can open up interactions with the data to a broader range of users. The visualization enables less technical business users to understand the complex data analysis and develop actionable insights. Again, I've done this before, presenting numbers to non-technical people. You see their face glazes over, their eyes glaze over. But when you present it in a chart or in a diagram, there's more interest and they can relate to it much more efficiently. Also, the visualization can surface data relationships that are difficult to see and understand with conventional office tools like Excel. Excel and those type of tools are good, but depending on who your audience is and the type of data you're dealing with, there are other tools that can help present the data more efficiently. And again, visualization, at the end of the day, all the work that we're doing from the data management side is to get to a point where you can do your data mining and visualizations to be able to present to the organization the business value and the investments that they're doing in the data management and analytics. Okay. Yes, another topic I wanted to mention was data virtualization. I've talked about it before. About creating, basically it's a single abstraction between the data and the sources and the query target. As you can see on the diagram, helps you eliminate the silos that are out there. You have put an enterprise data virtualization layer. It goes out and understands what data you have. So there's for people doing analytics, web analytics, or other use cases, they don't copy the data. They use the virtualization layer to go and get the data from the sources that are out there. And it's an approach to data management that allows an application to retrieve and manipulate data without requiring the technical details of where it is stored and how it's formatted. so organizations run multiple BI tools and database management systems. And this enterprise data visualization layers makes this data available to everybody, and you don't have to really concern yourself. You may not have to concern yourself with the technical nuances of the data, the database management systems you're dealing with. And the data virtualization provides users with real-time and reliable data. One way of looking at this, the analysts and data developers are not going to the data is coming to them. That enterprise layer provides with the data and provides the data that they'll need. Okay, business intelligence tools. Like I said earlier, there's a lot of business intelligence tools that are out there. Application software that collects and processes large amounts of data. The chart on the right just explains who the big players are. You have Tableau, you have Microsoft or Power BI. Those are the big ones. ThoughtSpot, and a lot of vendors have various products. And again, the ones big in the business world right now are Tableau and Microsoft, because they're able to process large amounts of data, and they help to prepare the data for analysis, so that you can create reports, dashboards, and data visualizations as well. And it gives you the power to accelerate and improve decision making, increase operational efficiencies. And data visualization software is for designing charts as well as for building BI, business intelligence dashboards. And I've been to a lot. I remember back in the day, we used to go to presentations and numbers were coming at you from all sorts of directions and reports. Now, the visualization tools have gotten very sophisticated. All these tools here are very sophisticated, very good, like Google's tools, MicroStrategy's tools. But it's much easier. They're much more sophisticated now so that they can present the same important information to your audience. You do all the analysis in the background, and then you render it using these tools so your customers can understand it. Okay, I'm sorry, that was a whirlwind of what's under the data management umbrella. I just wanted to put a little commercial here. The data management course that we offer, that MAC offers, you get to play with, as part of the course, you get to play with all these tools. You get to play with SAS. You get to play with Microsoft SQL Server, Hadoop, which is a big data tool. The Atacama tools will help you do profiling and data quality analysis. You have Power BI and Tableau to help do your reporting and some of your visualizations. So that's it. That's a whirlwind tour. I tried to slim this down, but this is like I said earlier, this is the bare minimum that you need to be aware of for data management if you want to get into the data management space. And they said and these are the minimal components that you need to be able to manage your data, to be able to do good analytics and also good operational reporting, those type of components. Okay, Madi.
Thanks everyone for staying up until now, and thanks Guido for sharing the very exciting and helpful insight about data management. I'll try to, if we can move to the next slide, I'll try to have a very brief overview of our data analytic program at McMaster Continuing Education. So basically, we started our program in big data analytic form in partnership with the DeGroote School of Business back in 2017. And after that, we evolved the program into 3 different streams, certificate streams, depending on our learners' need and their interest, to learn about data analytics, data science, and big data programming architecture. For those of you who are interested to learn mostly data analytics in application level, basic stream, basic level data analytics is the appropriate form of the program or certificate. And later on, you can move to more intermediate and experienced level streams, data science and big data programming architecture. So our instructors are professionals. Basically, they're experts in different fields, such as finance, manufacturing, retail, and telecom, you name it. And they're here to share their insight and knowledge with our students. Our courses are delivered in virtual live format, and our students are considered part-time. And the courses are scheduled mostly in the evening and weekends, So this gives a level of flexibility to the learner if they want to have a balance between their day job or their school time and our classes. So in our program, we have a good balance of concept and hands-on instruction. Students are exposed to a different type of industry tools. I mean, industry common tools. We don't want to overwhelm a student with tools or maybe cut from the learning just by focusing on the tools. We also have hands-on parts through our capstone courses or maybe in the experiential learning platform partnership with different industries. And students are working on real-world scenarios, real-world projects. For those of you who are familiar with some course topics under each program stream, we also have another level of flexibility offering a shorter certificate of professional learning. Instead of doing 5 courses from a collection of courses we have under each stream, you can only do a selected number of courses, 3 of them, or you can do one-off courses too. So again, thank you so much for joining us today. We hope you found this session useful and informative. If you are interested in learning more about these topics, please visit our website to register. We look forward to connecting with you soon. Thank you.
Thank you very much.